Okay, we have the key for the study guide. This is integration and accumulation of change, part 2. First problem, we see the integral from 1 to 2 of 1 over x squared dx. So this is one in which we need to rewrite it. We have to make this a situation where we have x to an exponent. So we're going to have to rewrite it as x to the negative 2 dx. Now it's ready to be anti-derived. That's our first step when we do the fundamental theorem of calculus. So that becomes x to the negative 1 over negative 1, and it's evaluated from 1 to 2. Now I've got to plug in the 1 and the 2. It might be hard to plug it in with these negative exponents, so I'm going to rewrite this. If I have x to the negative 1, I know that that's the same thing as bringing the x down into the denominator. Right? It's x to the first power, but I don't have to write the exponent. Keep in mind there is a negative sign down there already. Okay, so now I can plug in my 1 and my 2. The fundamental theorem says plug in the 2 first. So we have 1 over negative 2, or negative 1/2. It doesn't really matter where the negative sign goes, minus 1 over negative 1. Okay, so negative 1/2, and then minus negative 1. That's the same thing as plus 1. Negative 1/2 plus 1 is 1/2. So our answer is going to be C. With our second problem, I apologize for, I don't know what happened here with the printer, but what this was supposed to say is that u is equal to the square root of x, and we want to know the integral from 1 to 4 of e to the square root of x over the square root of x dx is equal to which of the following? Okay, so we know that u is equal to the square root of x, or another way of writing that is x to the 1/2. So du will be the derivative of x to the 1/2, or 1/2 x to the negative 1/2 dx. All right, now we don't see that at all on the page, so what we actually need to do is rewrite this du. Okay, what does that entail? Well, we see it's a negative exponent, so that means it becomes positive if we move it down into the denominator. And x to the 1/2 we know is the same thing as the square root of x. So that's our du right there. Now look at what du is. Look at what we have. We have the square root of x in the denominator. We don't have the 2 in the denominator, though. All right, so we need a 2, which means what we really have is that with that 2 in the denominator, we've really multiplied by 1/2. So on the outside, we need its reciprocal, and the reciprocal of 1/2 is 2. So this is a situation, normally we have the 2 on the inside and the 1/2 on the outside. Here's a situation where we need the 1/2 on the inside, so the 2 will be on the outside. So it's time to rewrite this. So the 2 is on the outside. That's the coefficient that's necessary, the collateral damage, if you will, from changing our function so that we have the appropriate du. Speaking of which, we can put our du in. We have the e. E was never touched. It was e to the square root of x, but the square root of x is u, so now we have e to the u. All right, so that eliminates D as an answer. Now the question remains, what are the bounds? And remember, we have to take the old bounds, which are 1 and 4, and we have to plug them into the u equation. All right, so u of 1 is the square root of 1, and u of 4 is the square root of 4. We know this to be 1. We know that to be 2. So the bounds are 1 and 2, and the answer, once again, is C. All right, with number 3, another fundamental theorem here. This time we have u is equal to x plus 1, and du is equal to just dx. This works out rather nicely for us. So we have the integral, and we're going to have u to the 1/2 du. We don't have any numbers on the inside or outside because du and dx are one and the same. All right, but we do want to change our bounds. If we plug 0 in, our new lower bound is 1. If we plug 3 in, our new upper bound is 4. Now it's time to actually go all the way to the end of the problem. Up here we stopped once we changed to u. Here we have to go further. U to the 1/2, we add 1 to the exponent. 1/2 plus 1 is 3/2. And then we have to divide by 3/2. And that's being evaluated from 1 to 4. Now again, we can plug the 1 and the 4 in, but it's kind of hard to do so when we've got rational exponents. So my recommendation would be to let's rewrite this. First of all, we're dividing by 3/2. Dividing by 3/2, we know, is the same thing as multiplying by its reciprocal, which is 2/3. So we have 2/3, and then we have u to the 3/2. All right, remember what happens here. The denominator of the exponent is our root, so it's a square root, and then we have u cubed. So we have 2/3, the square root of u cubed, and that's being evaluated from 1 to 4. So when we plug in the 4, we have the square root of 4 cubed, and then we plug in the 1, the square root of 1 cubed. Now obviously 1 cubed is 1, square root of 1 is 1, so we've got 2/3 here. What's happening over in the first part, we still have our 2/3, 4 cubed, 4 times 4 times 4, we know is 64, so this is the square root of 64, which we also know is 8. So 8 times 2 is 16, so we have 16/3 minus 2/3 for a final answer of 14/3. And the last one on this page, f is a linear function and a is less than b, but they're both greater than 0. What is the integral from a to b of f double prime of x dx? Okay, let's ignore everything right here and let's talk about solving this, because we can do this. All right, the first thing we have to do is take the antiderivative. And the antiderivative of f double prime is just f prime. And that's going to be evaluated from a to b. Okay, there's our fundamental theorem right there. Now, what's this equal to? Well, it's equal to f prime of b minus f prime of a. That's just performing the last part of the fundamental theorem. Plug in the top minus plug in the bottom. Now let's look at everything else, because we can't go any further at this point. Well, what do we know? F is a linear function. All right, well, that means that f of x is mx plus b. All right. Put some numbers in if you'd prefer. F of x is, I don't know, 3x plus 2. There it is. Okay, so if f of x is 3x plus 2, what's f prime of x? Exactly, it's just 3. So what do we have to do? We have to plug b and a into f prime. What's f prime of b? It's still just 3. What's f prime of a? That's also 3. So we end up having 0. And again, that's just with me picking a number. It didn't have to. If I left it as mx plus b, f prime of x would just be m. And f prime of b would be m, and f prime of a would be m, and we would have m minus m, which, once again, is 0. One way or another, we're ending up with that 0.